Today we're going to learn a little bit about molarity. Now, molarity is a unit of measure typically used for measuring concentrations of solutions. So what molarity stands for is the moles of a solute divided by the liters of a solution. Now for the moles of solute, that's simply just the substance that you are dissolving. And for the liters of solution, you shouldn't confuse this with liters of the solvent. It is the entire solution. So it's the solvent and solute all mixed together. It's the entire solution. So let's say we want to make a fully saturated solution of salt water. Well, when we go and do that, we were able to make a 500.0 milliliter aqueous solution with 179.5 grams of sodium chloride or table salt in there. And now we want to figure out what the molarity of the sodium chloride is. Well, to do that, we're going to start off by putting in our two variables that were given, the 179.5 grams of sodium chloride in the 500.0 milliliters of solution. Now, we want to try to get in units of moles of solute and liters of solution. So we're going to tackle the moles of solute first. And so, since I have grams of sodium chloride, I'm going to divide it by the molar mass, which we can use the periodic table to find out to be 58.44 grams of sodium chloride, again for every 1 mole of sodium chloride. So our units are going to cancel out for grams, and now we'll have moles of sodium chloride per milliliters of solution. So we're almost there. We just need to get milliliters into liters. And so we can say for every 1,000 milliliters of solution, we have 1 liter of solution. And so now if we cancel out all of our units, milliliters will cancel out with milliliters, grams will cancel out with grams, and we'll be left with moles of sodium chloride per liter of solution. And that will give us our molarity. And we'll find out that that is 6.14305 moles of sodium chloride per liter of solution. Now, one of the things with molarity is it can get a little cumbersome to write out moles of your substance divided by liters of solution every single time. So chemists try to be a little bit more efficient, or as someone might say, lazy. So there's another way to write out molarity. Another way to write out molarity is to simply write down a capital M. And so we'll do the same thing for here. So we're going to write out 6.143 molarity, or M, of sodium chloride. Alright. So let's say we want to dilute a solution. This is a very common practice. So whenever you're diluting solutions, you're essentially following the same steps, and typically with all these molarity type problems, as long as you keep track of your units, you should be okay. Occasionally what might happen is you'll find out that your units are flip-flopped, so you have the reciprocal of what you actually want, and all you have to do is just do 1 divided by that number and you'll get to the right solution. Or you can rewrite everything and essentially flipping what's on top and what's on bottom. So let's say we were trying to dilute a solution of hydrochloric acid. We have concentrated hydrochloric acid, which is 12 molar. This is normally how you can buy it from suppliers. And we want to make a 200.0 milliliter solution of 2.0 molar hydrochloric acid. And in order to do that, we want to figure out how many milliliters of the concentrated or 12 molar hydrochloric acid is required. So to start off, there's a couple different ways we could tackle this one. I would recommend that since we know more about the 2 molar solution, we know that the concentration is going to be 2 molar, we know the volume that we want, so this is essentially our variable that's dictating how many milliliters of the concentrated solution we'll need. So that's where I'm going to start. So let's say we have 200 milliliters of 2.0 molar hydrochloric acid. Now for this 2.0 molar hydrochloric acid, I put this in parentheses because this is just a label. What some people like to do is they like to write it out as a solution 1 or solution A. You can label it whatever you like. I normally like to do concentrations and what the substance is. Then we can say for every 1,000 milliliters of solution 1 or 2 molar hydrochloric acid, we will have 1 liter of 2.0 molar hydrochloric acid, or again we can say solution 1. Then we can say for every liter of 2 molar hydrochloric acid or solution 1, we will have 2.0 moles of hydrochloric acid. All right, now this 2 moles is coming from the fact that we know our solution 1 is 2.0 moles per liter. So that's essentially the equality we're putting here. So now that we have our answer in moles, now we can convert to the other type of concentration. So when we go to the other type of concentration, we'll simply put in our 12 moles of hydrochloric acid on the bottom for every liter of the 12 molar hydrochloric acid solution. Or another way of labeling this, if you want, is solution 2 or solution B, whatever works best for you. Then we can say and since our final answer is wanting milliliters, we can say that for every 1 liter of 12 molar hydrochloric acid or solution 2, we will have 1,000 milliliters of 12 molar hydrochloric acid or solution 2. All right. So now that we have all that worked out, we'll be left with milliliters of the 12 molar hydrochloric acid solution. And so we can multiply everything on top and then divide by everything on bottom. And when we do that, we will get 33.3 repeating milliliters of 12 molar hydrochloric acid. For this one, we're going to be good down to 2 significant figures, mainly because of we have 4 sig figs here. This is an exact equality, so that's not going to limit us. We're going to have 2 sig figs here for the concentration of our diluted hydrochloric acid. We're also going to have 2 sig figs for the concentration of the concentrated hydrochloric acid. And then this is an exact equality, so that's not going to limit us either. So we're limited to either having 4, 2, or 2 sig figs, and the less of those is going to be 2, so we'll be limited to 2 significant figures. So when we do that, we will end up with 33 milliliters of 12 molar hydrochloric acid. And so that's how we can do a solution. So I hope you enjoyed learning a little bit about molarity, and I look forward to seeing you on the next video.